Okay guys, so in this video we are still in chapter 5.4. In the previous video we explored long division, we practiced long division of numbers, kind of got a general understanding of why we do a long division of polynomials, because we are looking for factors. We are finding factors of a polynomial. And then we did one example. So guys, this video we are just going to be looking at a couple more examples. There are a couple special cases that might come up when we do long division of polynomials, so this video is going to address those special cases that may come up. This next one, number 2, I'm going to do is pretty standard, so I'm going to run through another one, and just to get a good practice of it. So I've got here 4x squared plus 23x minus 16 divided by x plus 5. Okay, so again, we look at those first terms, okay? I'm going to do x times, and on the side, I always do this, you'll see x times what equals 4x squared. I'm looking at these first, right here, x and the 4x squared. So x times what gives me 4x squared? I need a 4x. Remember, keep everything in line. So with common terms, like terms, and then we multiply. 4x times x gives me 4x squared. 4x times 5 gives me 20x. Parentheses, subtract. 4x squared minus 4x squared is 0. 23x minus 20x is 3x. Bring down the next term. And then we start over. I'm going to have, again, we still look at that x and the 3x in the front. X times what equals 3x? X times what is 3x? We need a 3. And that goes above the constant. Everything is above the like terms. It's positive because it was a positive 3 over here. And then we multiply. 3 times x is 3x. 3 times 5 is 15. Parentheses, subtract. 3x minus 3x is 0. Notice that always happens. If it doesn't happen, you did something wrong. Right here, that should be 0. Negative 16 minus 15 is negative 31. There's nothing left for me to bring down. So I'm done. Here's my remainder. Now my answer to this division problem, remember, is the quotient plus the remainder over the divisor. Notice my remainder was negative, so plus a negative is really just subtract. This is my answer to the division problem. This is the division. Look, 4x squared plus 23x minus 16 divided by x plus 5. Another way to write this is my dividend, the numerator, equals the quotient times the divisor plus the remainder, or subtract minus the remainder. Okay? So let's check out this next example here. We are going to set it up. It says 6x squared plus 7x plus 2 is divided by 2x plus 1. I set it up. I look at those first terms. 2x times what gives me 6x squared? Well, I'm going to need a 3 and another x. Again, that goes above the 7x because we've got like terms. 3x times 2x is 6x squared. 3x times 1 is 3x. Parentheses, subtract. 6x squared minus 6x squared is 0. 7x minus 3x is 4x. Bring down the next term. Guys, remember those parentheses here. And the subtract, we're distributing that subtraction sign. That's why this is a 4 and not a 10. When you go straight down, we've got to remember to subtract. And then we'll start over. 2x times what gives me 4x? Well, I just need a 2. So then I throw that up here with the quotient. 2 times 2x is 4x. 2 times 1 is 2. Parentheses, subtract. 4x minus 4x is 0. 2 minus 2 is 0. There's no remainder. My answer to this division problem is the quotient. If I can also write this as the dividend equals the quotient times the divisor. Order doesn't really matter. And this, it's easier to see, guys. Notice we can factor that, right? I could have given you this in the last couple sections. Factor 6x squared plus 7x plus 2. If you factored it, you get these binomials as your factors. So what long division is if I'm given one of the factors, I can do long division to find the other factor. Just like if I gave you the number 32, and I said, okay, I know 32, if I have 32, I know 2 is a factor. Give me the other factor. You would do division to find that 16. That's exactly what long division is. Okay, 4 and 5, these next ones are extra practice for you if you'd like to do them. What I want to point out here is these 2 special cases that are going to come up. The first one is make sure before you do the long division, anytime you do division, we have an equation written in standard form. So for example, look at 6. I've got x cubed minus 30x minus 18 minus 4x squared. Right away, you notice this is not in standard form. So when you set up your division, you need to make sure it's in standard form, or else you'll get a wrong answer. Notice even this, 3 plus x, that should look weird to you by this point. That's not in standard form. That should be x plus 3. And now you can go through and do your long division. Let's try this one. X times what gives me x cubed? I need x squared. X squared times x is x cubed. X squared times 3 is 3x squared. Parentheses, subtract. X cubed minus x cubed is 0. Negative 4x squared minus 3x squared is minus 7x squared is a negative. Bring down negative 30x. And then we start over. X times what gives me negative 7x squared? Well, negative 7x minus 7x. And then I multiply negative 7x times x is negative 7x squared. Negative 7x times 3 is negative 21x. Parentheses, subtract. Negative 7x squared minus negative 7x squared is becoming a 0 because this is plus. Negative 7 plus 7 gives me 0. Negative 30x minus a negative 21x is negative 9x. Bring down, start over. X times what is negative 9x? Negative 9. Multiply through. Parentheses, subtract. And we ended up with 9 is my remainder. The answer to this division problem is x squared minus 7x minus 9 plus the remainder over the divisor. Okay, the last special case that I want to talk about is really important. For any missing degree or exponent terms, you must include a 0 placeholder, and this is for the dividend or the divisor. So let's check out this problem here. Notice, we'll start to set it up. X cubed plus 4x plus 1. Right away, see how we're missing an x squared term. If you think about standard form, look at this one. I've got 3, 2, 1, nothing, 0. I need to have a spot. Remember, I've been talking about this whole time. All of your like terms are in a column. I need room for all of the like terms. So notice what we have to do. What we have to do is have a 0 placeholder, because I'm going to have terms that have an x squared in it, and I need to have a column to put them all, divided by x minus 2. So it's really important to be on the lookout for that. And then we just do this like normal. X times what is x cubed? See, right away, you know, where am I going to put that x squared? I need a spot for it. And then we'll multiply. And then we'll subtract. X cubed minus x cubed is 0. Watch out here, guys. 0x squared minus a negative 2x squared. 2 negatives make a positive 2x squared. Bring down. Bring down. Parentheses, subtract. 17 is my remainder. Answer is the quotient plus the remainder over the divisor. Okay. The last thing that we're going to check out here, guys, is just to start to get an understanding of the factors. So here, for example, it says if the remainder is 0, you have found a factor of the original problem. From there, you may be able to factor the quotient further using other techniques, and this is why we learned how to factor. So if I know, they told me x plus 2 is a factor of this dividend. So right away, I know I'm going to get 0 as my remainder. What that then tells me is, let's practice writing it in the other form. The dividend equals the quotient times the divisor. Tells me that if I multiply these two things, I'll get this polynomial. It wants me to find the other factors so I can keep factoring this, right? I need two numbers that multiply to -6 and add to -5. That's going to be -6 and a +1. Here are my other factors of this dividend. Okay, so we might have to do that for some types of problems. We need to do the division. Then I've got our factor is the divisor and the factor is the quotient. That's why we write it here. And then we keep factoring it to find the other factors. Math gets hard because we use the word factor is a verb. It's something we do, right? I just factored this trinomial into these two binomials. I factored it. But then it's also a noun. This is a factor. There are 3 factors of this polynomial, okay? It's something we do, and it's something we call a binomial or a trinomial, okay? So guys, this is the first section that we're talking about, is just long division of polynomials and then being able to fully factor a polynomial from doing division. Great job, guys. You are going to start to practice long division.